Okay, today's lessons will be on 4.1 and 4.2 that we've been talking about, but we're going to focus on application problems. So, word problems that would involve when we have to find a vertex because we'd be looking for a minimum or maximum. So, when I look at this first example with this picture here of this graph, this would be the picture of over time in seconds. What would be the height of a ball? So, a ball is kicked or thrown or something like that. So where it starts on the ground and then it raises, it hits a height, and then it falls back to the ground. Um, this is a very common type of application problem with quadratics. So answering these questions here, does the graph have a minimum or maximum? So when I take a look right here, this graph would have a maximum. Okay, what time does the ball reach its maximum height? Well, here's my maximum height. The time that occurs would be 2 seconds. Okay, what is the maximum height of the ball? So here would give me my maximum height. So that would be 2,000. We're in centimeters. What is the vertex of the graph? The vertex would be 2, 2,000. And then how does question 4 relate to questions 2 and 3? Well, question 4 asked me for the vertex, and you found the x-coordinate of the vertex and the y-coordinate of the vertex in problems 2 and 3. So you can write this out, but it's really more so of a discussion point in class at how they relate, because what you're going to see in your word problems is they're going to ask you questions like, what time does the ball reach its maximum height? And you'll need to figure out that means, oh, that means they're asking for that x-coordinate of my vertex. So you're not going to be given a graph, you're going to be given the equation. And then we'll look at the equation and go, well, how do I find the vertex of that equation? Find that x-coordinate. And then if they ask me what is the maximum height, well, that means I'm finding the y-coordinate of the vertex. So that means I got to calculate that. So they're going to ask you for certain parts of the vertex when we're doing these word problems. So the math isn't anything more difficult than what we've been doing or anything new. It's just recognizing which part are they asking you for. So which part of the math do I need to do? Okay, is the part that is new. All right, so we'll take a look at a word problem example here. So we have the Big Brick Bakery sells more bagels when it reduces its prices, but then its profit would change. So we have a function there. So we have that equation, and that models the bakery's daily profit in dollars from selling bagels, where X is the price of bagel in dollars, and the bakery wants to maximize the profit. Okay, we have looked at maximizing profit problems. We did that in linear programming, but this problem is not linear. It doesn't make a line. This is a parabolic type profit. Okay. The first part I want you to think about when you're doing every word problem is to think about as a point on a graph, what is it representing? What is my input variable, which in this case they use X, and Y. Not all of our problems will use X and Y. Sometimes they'd use T for time and H for height, like in the last problem that we had. So we need to make sure that we are understanding the input variable, so what I'm replacing that's inside the problem, what that's represented by. Yes, it's X, but X is the price of a bagel. So that is the bagel price. So if anything asks me about the bagel price, when I go through these problems, they are asking about the X value. Okay? When I plug in my input of a bagel price, the Y value is the output variable. That's what we get back out. So that function is representing the daily profit. Okay? So we want to keep that in mind when we start asking these questions below, so we know which variable they are talking about. Okay? All right, so for part A, it says, what is the domain of the function? And then what would be the real life domain for this situation? So just that equation, if you remember, we've been talking about domain and range from the previous week. Domain was always oops, I was gonna put a dollar sign. I don't know why. Is always all real numbers. Okay. But now realistically, my X value it represents the domain. That's bagel price. Can we realistically say, well, any price would be fine? No, it doesn't make sense in reality. Okay, we can't charge -$4 for a bagel. I mean, you could also argue we can't charge, $20 for a bagel. But realistically, at least, we've got to be greater than 0. And then, yes, at some point, there's going to be a price that we get to where we wouldn't make any money because people wouldn't buy a $30 bagel. Okay. That's for a later discussion when we get to more problems where we get to more solving problems. Right now, we can just think about that it can't be negative, okay, in reality. So something to think about there. That's the only time we'll ever see our domain change with our quadratic functions is when we get in a real world situation. So we'll get more into that as we get further into this chapter, but that's just more just to kind of process for you. Okay. All right. So for part B, I want you to find the daily profit. So the daily profit would be the output. So that's Y. For selling bagels for 40 cents each and for 85 cents each. So each of these would be a bagel price. So those are your input variables. You're going to find out if you charge 40 cents, what do they make? And if they charge 85 cents, what do they make? Okay, so you will want a calculator for today's lesson and today's homework. Word problems are kind of messy. All right, that's live. So I'm going to plug in place of the X, the 40 cents. And I'll do the same with the 85 cents. Okay, if you've got a nice calculator where you got parentheses and you can see your screen, you can type it in just exactly the way I have it written if you're using parentheses. If you are not, then make sure you're taking your 40 cents minus your 55 cents, squaring that, it'll come out positive, multiply it by -1,000 and add 300. I'll tell you what these answers are right now, but make sure that you know how to calculate this yourself as well on your calculator. So double check that you are getting these correct answers here. So I'd get $277.50 if I charge 40 cents. And if I charge 85 cents, they would make $210. Okay, so what we sometimes have here as a class discussion is we talk about, well, if you charge more money, why, like we charge 85 cents, you think you make more money if you have a higher price for your bagel. And so we talk about why doesn't that make sense? And then usually students eventually say, well, if you charge too much, less people are going to buy those bagels. So we want to kind of try to find that magic price that would give you the most profit is kind of what this problem's thinking about. And that's why it's in a parabolic shape, or it makes that parabola. There is a point where we get the maximum amount of profit. So this would be your profit. And we want to know that price that we would need to charge to get to that profit. So right now, if we go 55 cents, that's better than going 85 cents. So that 85 cents is going to fall past that magic spot of that vertex there to get to the maximum. And that we don't know quite yet if 55 cents is the best or if we could find something better. But that's why this graph should make sense in this problem. All right, so for part C, what price, so the price is X, so what X value should the bakery charge to maximize its profit? All right, maximize, when we're talking about a parabola, right, that is my vertex right here. That is going to be the maximum. Okay, so we are looking for the vertex. And since it asks for price, we are looking for the X coordinate of the vertex. Okay, so I need to take a look at the equation I'm given. Go back up here. And we need to think about what form that is in. Is that in vertex form or standard form? And then my students will be like, oh, that's vertex form. Okay, so if it's in vertex form, we actually already have the vertex. Most of your problems are going to be in standard form where we'll have to use negative b over 2a, but we don't have to do that here. Basically, we're given the answer in the problem. So that would be the x coordinate of my vertex. So 55 cents is going to be the best price. And what is the maximum profit here? Well, there's the y coordinate of this vertex. So this point right here is the point 55 cents and 300. So they make $300 when they charge 55 cents. When we charge 85, they make less. When we charge 40 cents, they make less. It wasn't enough for each price to make as good of a profit, but a lot of people probably bought bagels. All right, so that's their magic price, is that 55 cents. And when I say what is the maximum profit, profit, remember, are your y values. And so now it wants that y coordinate of the vertex, since it's asking for that maximum specifically. Part C wanted the price to reach the maximum. So the price to reach is 55 cents. The actual maximum is that $300. Okay. All right, let's take a look at another example here. So example 2, the height of a batted ball is modeled by the function below, and then x is the horizontal distance in feet from the point of impact with the bat, and h is the height of the ball in feet. So this first part, I want you to think about this again before we answer questions for A and B, is to make sure we understand our input variable, yes, is x, but I'm not asking you what letter is the input variable. I'm asking what is it representing? Okay, x is the horizontal distance. Okay, and then h, yes, h is the letter for that output variable, but what does h represent? Well, when I plug in a horizontal distance, what do you get? H is going to be the height of the ball. Okay. All right, so let's go ahead and try to answer parts A and B so we can pay attention to what they're looking for. So A says at what distance from the batter? So we're looking for a horizontal distance. So that's our x value. Will it be at its maximum height? Maximum means we're looking at the vertex of this graph, but I want the x coordinate of your vertex. Okay, so when I take a look at my equation right here, I need to think about that is in standard form. So if I'm finding the x coordinate of the vertex in standard form, I must use negative b over 2a. Okay. So then my b value would be this 1.2, so or 1.22. So I'll have negative 1.22 divided by 2 times my a value is negative 0.01. Okay. A lot of the problems when we've been doing our negative b over 2a have been maybe easy ones to do in your head. These ones are going to get a little bit messier, so I'll see more students use their calculators. So make sure you're not typing it in as negative 1.22 divided by 2, then times negative 0.1. You're going to need to put parentheses around that if you do it all at once. Or make sure you are multiplying 2 times negative 0.01 to get negative 0.02, and then you're dividing those two values. Okay, and then I will get 61, and this is a horizontal distance in feet, so that would be 61 feet away from the batter. And then part B is asking, what is the maximum height of the ball? or what is the maximum height that it will reach. So the maximum, yes, clues you into your vertex, and it wants the actual height. So I want the y coordinate of my vertex. So we have the x coordinate from part A, so I need to plug in that horizontal distance to get that height. So in this case, y would be h. So h equals negative 0.01. 61 needs to be squared, plus 1.22 times 61, and plus 3, where this then just becomes a calculator problem. So like I've said before, if you've got a nice calculator, graphing calculator, scientific calculators, where you could just plug all that in at once with those parentheses and the squared, that would be fine. Otherwise, do it a little piece at a time. Big things I see students forget is to square that first, or to square it at all. A lot of them will forget to square it. Notice this is negative. Okay, so what's nice with the word problems is if I got something like a negative answer for H, that wouldn't make sense. Or, you can kind of start to go, is this realistic? So that part's nice to kind of check your work. But make sure you're testing this out in your calculator. I see a lot of students that know how to do these types of math problems, but then all their answers are wrong. Okay, because I think they don't take the time in class to check to make sure they can do it on their calculator. They just wait till I give them the answer and say, yep, this is going to be 40.21 feet. I believe I can't remember if I rounded that or not. Math Excel will tell you what to round to, because a lot of times these problems won't turn out really nice necessarily with every problem. But like I was saying, a lot of students will go, yep, I get how to do that. I plug it in. We get this answer. Cool. That's great. And they don't practice putting it into their calculator. And then they find out when they get to their homework, they're getting them all wrong. Or when they get to the quiz or the test, they're doing it all wrong. Okay, so make sure you check that works in your calculator. Make sure you're asking questions if you're not sure why it's not working. You don't want to get something wrong because you don't know how to use your calculator properly. All right, that is it for our lesson today. Good luck on your homework, and as always, reach out if you've got some questions. Bye.